I'm going to do the exercise that's called Solar Systems Activity. I can show you the video on the exercise on the tabletop here, and you can complete this exercise from the Google Classroom. I'm on step number 1. Part 1 says day and night. The materials I need is a flashlight and a ball. Place the flashlight on its side on the table and turn it on. Place the large ball on the table beside the light. Sketch the ball and show the light and dark sides. Label it day side and nighttime side. You might have a hard time doing this sketch on here unless you can figure out how to draw on the computer and then input it. But let me show you what I mean by this. Here's the flashlight. I'm going to set it there. Here's the ball. I'll put it right here. At this time, you can see on this side of the ball, lots of light, daytime. On the back side of the ball, it's in the shadow, it's nighttime. Part number 2 says eclipses. I need a flashlight and 3 different size balls. I'll use these and this flashlight. Place the flashlight on the side and turn it on. Place the large ball on the table. Sketch the ball and show the light and dark sides. This is the same as we just showed, really. Here's the light side and the dark side. There's no eclipses here. Step number 4 says add a middle-sized ball in between the flashlight. At this time, we're getting a partial eclipse. There's a little bit of light being blocked here by the middle-sized ball on the large ball. This is a partial eclipse. Step number 6 says add a small ball anywhere on the far side of the large ball so that it is completely in the dark. Take this one out. Okay. In this case, we have all the light being hitting here on the large ball, and the shadow is being cast on the small ball, and there's no light really getting hit on the small ball. I can see a little bit of light there. Maybe I should move this back over here. And it looks like there's no light hitting the small ball. This would be a total eclipse. Here is part number 3, craters. I need some modeling clay and some different size balls again. And it's going to ask me to roll out the clay to 1 centimeter thick. I'll randomly drop the balls on the clay. Repeat steps 2 with other balls several more times, and then sketch the top view of the pan and the sand craters. Okay, I've done what I can to roll out the clay here. My little rolling pin. And then I'm going to take my balls and drop them on there. That ball does a little bit better. It's harder. It's a little bit softer. It's a little bit big and very soft. It's a little bit hard to see, but the idea here is that some of the balls imprinted the clay and left craters. Step number 4 says seasons. I need 1 ball for the sun and 1 ball for the earth. It says place the sun ball in the center of the table and place the earth ball to the left. How long does it take for the earth to rotate once on its axis? How long does it take for the earth to revolve around the sun? Step number 5 says sketch the model. Label this summer. Advance the ball along its orbit for 90 days. It rotates counterclockwise, which means for me it'll be coming down to here. If you can see that, it's on the bottom side. Now 90 days later, it's gone from summer to fall, and your sheet asks you to sketch that as autumn. Step number 7, advance the ball another 90 days, which would make it over here. This would be after fall, winter. And then step number 8 says advance it again 90 days up to here. And this will go from winter to spring. and then another 90 days would take it back to summer. You need to sketch those seasons. On part number 5, it says the moon's rotation and moon's revolution around the Earth. We need a ball to represent the Earth. And we need a ball to represent the moon. And then I'm going to find a sticker. It says place the Earth on the table. Place the moon ball on the table. Then place the sticker on the moon ball on the far side. I'm going to place that sticker right there, if I can. I'm going to put it on the far side of the Earth, which will allow it to sit there. That was step number 3. Step number 4 says sketch the model. Add the arrow toward the sticker, and that's the far side of the moon. Step number 5, advance the moon along its orbit for 7 days. It rotates counterclockwise for 7 days, and it revolves counterclockwise for 7 days. Now what that's going to do in step number 5 is get this to turn down to what I call the 6 o'clock position. And not only is it going to revolve, but it'll rotate at the same rate. So this star now is very close to me. I don't think you can see it on the camera. Okay, sketch this model after 7 days. This would be day 8. And add the arrow on the far side of the moon, which would be over here. Step number 7, advance the moon ball along its orbit another 7 days. It's going to rotate and revolve at the same rate. 7 days later, it's going to be over here. Notice the stickers on this far side. This will be the sketch for day 15, far side of the moon. Advance the ball along its orbit for another 7 days. Step number 9, it's going to revolve and rotate at the same rate. 7 days later, it'll be here. Now, if you can see the star shape is right there on the end. And you want to label that on day 22. The idea with the revolution and the rotation of the moon is that it rotates and revolves at the same time. And when you're on Earth, you're always looking at the one side of the moon. When you're on Earth, you can never see the far side of the moon. We only were able to see the far side of the moon when we took the Apollo missions up there, and they orbited the moon and took pictures of the far side of the moon. Okay. We're on Solar System Activity, Part 6, Gravity. Step number 1 says slowly roll a ball across the table. Go like this. Where does the force from the ball come from? Step number 2, where does the force that moves planets come from? Step number 3, hold the ball in air. Let it fall. Where does the force on the ball come from? Step number 4, where does the force that keeps the planets in orbit come from? Step 7, density. We need 3 size balls, a meter stick, and a digital scale. And we're going to check the density of the balls. Step number 1, consider the balls as small, medium, and large. Small, medium, large. Predict which ball is the densest, the second densest, and the least dense. Record your predictions in the table. Of the 3 balls that I have here, this one feels like a little hollow rubber ball. I think it's a dog toy. This one is a foam ball, like a Nerf ball. This one is for lacrosse, I believe. This one's definitely the most dense, the middle one. Out of these 2, I'm going to recommend that this is more dense than this one. This feels a little bit heavier. This is really the lightest one. So I have written on my page, the most dense is medium, next dense is the large, least dense is the small. Next, I'm going to put those on the digital scale to get a reading for grams. The small ball grams are at 3.6 grams. Okay, I got it to stay on there by itself. The grams for the medium ball is 149.7. 149.7 grams. And the large ball. The large bar on the digital scale is 131.6. 131.6 grams. Next, it asks me to check the diameter of the small ball. This is the distance all the way across the ball. This one is 4 centimeters. Small ball is 4 centimeters. The diameter on the medium ball, 6 centimeters. And the diameter on the large ball, 8 centimeters. That's 4 centimeters, 6 centimeters, and 8 centimeters. Those dimensions are going to allow me to calculate the volumes of these balls, and then I'll have the mass and the volume, and I'll be able to do the calculation to get the density. After I calculate the diameter, it asks me to calculate the radius. I'm on step 5. I can calculate the radius of the small ball by dividing the diameter by 2. 4 centimeters divided by 2 is 2 centimeters. The medium ball diameter is 6 centimeters divided by 2 is 3 centimeters. And the large ball, 8 centimeters divided by 2 is 4 centimeters. And that'll give me the radius of those 3 balls. If I go down to step 6, it says calculate the volume of the small ball. The volume of the small ball is 4/3 pi times radius cubed. And I'll try that on the calculator here. 4 divided by 3 times 3.14 times 2 times 2 times 2, or 2 cubed. I have that at 33.5. The volume is 33.5 cubic centimeters. And here's the next one. I'm going to take 4 divided by 3 times 3.14 times 3 times 3 times 3, which is 3 cubed. And I got 113 cubic centimeters. And the last one there, the large ball, 4 divided by 3 times 3.14 times 4 times 4 times 4, which is 4 cubed. And I got 268 cubic centimeters. Finally, for my last column, and this is step number 7, calculate the density by taking the mass divided by volume. For the small ball mass, 3.6, divided by the volume, 33.5, and I got 0.10 grams per cubic centimeter. The medium ball, I'm going to do the mass, 149.7, divided by the volume, 113, and that is a density of 1.3 grams per cubic centimeter. And finally, the last density, the large ball, is 131.6 grams divided by 268, which is the cubic centimeters, and I got 0.49 grams per cubic centimeters. As I look back at these 3 answers, the least dense is the small ball at 0.1. The middle density is the large ball at 0.49. And the most dense was this medium-sized ball, 1.3. And that gives you practice calculating density. Okay, good. Finish that off. turn it in. Thank you.